Okay, we're going to talk about horizontal and vertical scale changes. So before I do that, I just want to go over an example where we know what happens when we scale horizontally and vertically, and that's the line. Okay, so first let's start with y equals x. That's our favorite line that has slope 1 and passes through the origin. Okay, so this line looks like this. Now what happens if I scale x? So let's say I replace I replace x here with 2x. Okay, so if I do that, I end up with this new line, I'll draw it right here, that has a steeper slope, a slope of 2. Actually, let's go ahead and I'll go over that in blue so that it's really easy to see. Okay, so our blue line is y equals 2x. Now notice that's much steeper. Okay, now what did that do if we think about it as a scale change, a horizontal scale change? So notice what it did is it kind of pushes the x's together. It compresses the x's. Okay, so before, to get the y value that is, say, here, we had an x value of, I'm going to guess that's 1. Now when I scoot over here to get that x value, I only need 1/2. Okay, so what I'm saying is, if this is my y value of 1, so before in my original line, I needed to go out to x equals 1 to find that y value. Now I only need to go to x equals 1/2. Okay, so it's compressing the x values. So for all of the y values now, the x values are getting squished in, okay? So now what about the line, what if I replace what if I replace x with 1/2 x? Okay, what happens there? Well, that's a line that has, actually let me do this one in green. Okay. So this line has less steep of a slope. It looks something like this. Okay. Now here, the x values are getting stretched out. So now we can see to get an x value of 1, I actually have to go out here, out to like 2 about. Now, okay, so what does that tell us? That when we replace x with 2 times x, we compress our x values. When we replace x with 1/2 x, we actually stretch out our x values, okay? And that kind of makes sense. What it's saying is that to achieve some y value, we need only half of the x value that we needed. We need twice the x value that we needed before, okay? So before we just needed 1 on this line, now we need 2 to get that same y value. It's stretching out the x values. So that, again, this is kind of unintuitive. We replace x with 2x to get some compression in the x direction. We replace x with 1/2 x to get stretch in the x direction. Okay, so this tells us that the horizontal, so let's remember f is our function, c is some constant greater than 0. So if c is greater than 1, then if we replace x with cx, we get a horizontal stretch. Oops, that's not how you spell stretch. By a factor of 1/c. So when we first replaced x with 2x, we compressed to by a factor of 1/2, okay, 1/2. Okay, now if c is less than 1, so if c is some fraction, replacing x with cx, we get a horizontal compression by a factor of 1 over c. Okay, so when we replace x, or x with 1/2 x here, we actually, oh, I'm sorry, this should be the opposite way. This is the wrong word. Compression, and this one is stretch. I apologize. Okay, so before, when we replace x with 1/2 x, okay, so notice c is less than 1 there, we get a stretch, right? We're stretching out our x values by a factor of 1 over c. There, that's 2, so we're stretching all of our x values by a factor of 2. Okay, above, when we replace y with 2x, we get a horizontal compression. We squish all of our x values by a factor of 1 over 2, 1 over c. Okay, now what about if we do replacing these with y with factors of cy? So again, let's start with our line y equals cx. Or excuse me, y equals x. Okay, so there's our line y equals x. Now what if we replace y with 2y? Okay, now notice that we would rewrite as y equals 1/2 x. But what have we done there? We've replaced y with 2y. And when we did that, we ended up with this line, right? Oops, I'm sorry, I don't want that to be blue. So line 1/2 x looks something like this. Okay, so what did that do to our y values? Well, it compressed them down, okay? So now, before they were bigger, now they're smaller. See, we're pushing all of our y values down. Okay, so replacing y with 2y compressed our y values by, it's going to be a factor of 1 over c, which is 1/2, okay? It compressed. Now, what if we replace y with 1/2 y? Well, we would rewrite that y equals 2x. Now, when we graph that, we get this line. Okay, now what did that do to our y values? It stretched them out. Okay, so see, before we had smaller y values, now they're larger. Okay, they're increasing. So that's a vertical stretch of a factor of 1 over 1/2, which is 2. So we're stretching by a factor of 2. Okay, so let's rewrite this. So replacing y with cy, we get a vertical compression. Now this is for c is greater than 1 by a factor of 1 over c. And then replacing y with cy, we get a, again, vertical stretch by a factor of 1 over c. Okay, so if we replace x or y with c less than 1, c times x or y, we end up with stretching. Okay, so replacing it with a fraction times that variable stretches in that direction. Replacing it with some number bigger than 1 times that variable gives us a compression, okay, in either direction.